The science behind tornado formation. Tornadoes don't just appear out of thin air. They're born inside massive thunderstorms called supercells, which contain a special ingredient, rotation. When warm, moist air from the ground meets cold, dry air from above, the difference in temperature and wind direction causes the air to start spinning horizontally. Then, a strong updraft, a vertical rush of air, tilts that rotation upright, forming what meteorologists call a mesocyclone. If conditions stay perfect, that rotation tightens, speeds up, and stretches downward to the ground, creating a tornado. This process might sound simple, but it's an incredibly delicate balance of temperature, humidity, and wind shear. A single degree of temperature difference or a small shift in wind speed can decide whether a thunderstorm stays harmless or turns deadly. Measuring tornado power. The Enhanced Fujita Scale. The most common way to measure tornado power is the Enhanced Fujita Scale, or EF scale. It classifies tornadoes from EF0 to EF5 based on the damage they cause. EF0. Light damage. Small branches broken, shingles ripped off. Wind speeds range between 65 and 85 miles per hour, 105 to 137 kilometers per hour. EF1. Moderate damage. Roofs peeled off, mobile homes pushed off foundations, cars moved. Winds reach up to 110 miles per hour, 177 kilometers per hour. EF2. Considerable damage. Houses lose entire roofs, large trees snapped. Winds push 135 miles per hour, 217 kilometers per hour. EF3. Severe damage. Entire stories of homes destroyed, trains overturned. Speeds reach 165 miles per hour, 266 kilometers per hour. EF4. Devastating damage. Houses leveled, cars thrown hundreds of yards. Winds exceed 200 miles per hour, 322 kilometers per hour. EF5. The monster category. Winds surpass 250 miles per hour, 402 kilometers per hour. Entire neighborhoods are wiped clean off the map. But here's the shocking truth. The EF scale is based on damage, not actual wind measurements. That means many tornadoes could be stronger than we realize. We just don't have instruments that survive long enough to measure them. The raw energy of a tornado. Tornadoes may look small compared to hurricanes, but their energy density is off the charts. A strong EF5 tornado can release energy equivalent to a small nuclear bomb. Imagine a swirling column of air, several hundred meters wide, rotating at speeds faster than most cars can drive, lasting for minutes or even an hour. To put it into perspective, an EF5 tornado releases roughly 10 trillion joules of energy per second. That's about the same as detonating 10 tons of TNT every second. If that kind of power were directed straight into the ground, it could shatter concrete like glass. Why tornadoes accelerate so quickly? The secret behind their insane speed lies in a principle called conservation of angular momentum. When a large column of air narrows into a smaller funnel, the air speeds up, just like a figure skater spinning faster as they pull their arms in. At first, a storm's rotation might only be moving at a few miles per hour. But as it tightens, those same winds can accelerate to over 250 miles per hour, 400 kilometers per hour. The smaller the funnel, the faster it spins. That's why some tornadoes can move entire vehicles and toss them into the air like toys. Tornado width and size versus power. Not all tornadoes are thin, whirling ropes. Some of the most destructive ones are enormous, over 2 miles wide. The larger the tornado, the more surface area it has to cause destruction. But surprisingly, size doesn't always mean power. For example, a narrow EF4 tornado can cause far worse destruction than a wide EF2. What matters most is wind speed and pressure difference. However, massive wedge tornadoes that appear like solid walls of clouds often combine both massive size and violent rotation, leading to catastrophic damage across entire towns. The physics of pressure. Drop. One of the most dangerous aspects of a tornado isn't just the wind, but the sudden drop in air pressure inside the funnel. A powerful tornado can have an internal pressure 100 millibars lower than the surrounding air. That might not sound like much, but it's enough to make buildings explode outward as the higher pressure inside pushes against the low pressure outside. This rapid change is also what causes your ears to pop when a tornado passes nearby. The air pressure around you changes faster than your body can adjust. How tornadoes lift cars and debris. When people see cars tossed around like paper, it's not just the wind speed, it's the air pressure and updrafts working together. Tornadoes generate both horizontal and vertical forces. The spinning motion lifts objects by creating a vacuum effect, while the strong updrafts pull them upward into the funnel. In stronger tornadoes, entire houses can be lifted from their foundations. Scientists have even found debris, like receipts, photos, and wood fragments, carried hundreds of miles away. That means a piece of someone's home in Oklahoma can end up landing in Missouri within hours. The fastest tornadoes ever recorded. The fastest tornado wind speeds ever recorded come from the 1999 Bridge Creek Moore tornado in Oklahoma. Doppler radar measured winds at a staggering 302 miles per hour, 486 kilometers per hour. The fastest wind speed ever observed on Earth. That's faster than the top speed of most Formula One cars. At that velocity, a car becomes as dangerous as a missile. Entire steel beams were bent, asphalt was peeled off roads, and even heavy farm equipment weighing tons was thrown across fields. It's hard to even comprehend that level of force. It's raw atmospheric violence at its peak. The path of destruction tornadoes can carve paths over 50 miles long, but it's their unpredictability that makes them terrifying. They can change direction, split into multiple funnels, or disappear entirely within seconds. Multi-vortex tornadoes, which contain smaller rotating suction vortices inside the main funnel, can multiply the destruction, each mini-vortex rotating faster than the main tornado itself. Afterward, the ground looks like a war zone. Trees are stripped bare, vehicles are unrecognizable, and foundations are all that remain of houses. Satellite imagery often shows scars on the land, wide brown paths marking where the tornado's fury ripped through. The sound and sensation of a tornado. Survivors often describe tornadoes as sounding like a freight train or a roaring jet engine. That's the sound of debris, pressure changes, and violently swirling air colliding all at once. In the moments before impact, the air feels heavy, eerily still, and often greenish due to how the storm clouds filter sunlight. Animals grow restless. Birds go silent. And then chaos hits, the sheer sensory overload of a tornado. The noise, the vibration, the air pressure is something no video or sound recording can fully capture. It's nature at its most terrifying and powerful. Why tornadoes are so hard to predict. Despite decades of research, predicting exactly where and when a tornado will form is still one of meteorology's toughest challenges. Radar can detect rotation within storms, but knowing which ones will actually produce a funnel is uncertain. Tornadoes can form and touch down in less than a minute, leaving almost no warning. Scientists are developing high-resolution models that simulate storms in real time, using AI and machine learning to detect patterns humans can't. But even with this technology, tornadoes remain one of nature's most unpredictable forces, the hidden power we can't see. Even after the winds fade and the skies clear, tornadoes leave invisible scars. Soil can be compacted, ecosystems destroyed, and communities displaced for years. The psychological toll, the fear of every thunderstorm afterward, can last a lifetime. When we talk about the power of tornadoes, it's not just about speed or energy. It's about how a single event can reshape entire landscapes, rewrite lives, and remind us how small we really are in the face of nature's fury.